Okay, so for the following circuit, we have to find the energy stored in these two capacitors. So let's start by finding the current passing through the two capacitors. So the current passing through a capacitor is equal to the capacitor times the change in voltage over the change in time. We're going to assume that time is infinite right now. So this one will be infinity, and the change of voltage over infinity will be 0. So I will be equal to 0. So that means the current passing through here and here is 0. And that means we can treat this, we can put an open wire here, okay? So that means we can pretty much ignore these two parts of the circuit. So now the circuit looks like this. Okay, so this is 1000 ohms, 3000 ohms, 6000 ohms, and this is 10 volts. Now let's find the current passing through it. So it'll be 10 equals 1000 plus 3000 plus 6000 times I, the current. So let me see what that gives me. Hold on. Alright, so the current is 0.001 amps. Okay? So now let's go back to our original circuit. Let me get rid of these. Now, so the current passing through this entire area is 0.001 amps. Okay? Or 1 milliamp. Now, let's find the voltage stored at each capacitor. So to find the voltage at this capacitor, it'll be equal to the difference of voltage from here to here, okay? Let's start by trying to find out the voltage at this point. So as the as current passes through here, there'll be a voltage drop. So since this is 10 volts here, it's going to be 10 minus 0.001. Hold on, 0.001. Yeah, 0.001 times the resistor, which is 1000, and that gives you 9. So as the current hold on, oops. As the current passes through here, it will be 9 volts at this region, and this region is 0 volts. So this is the ground node. That means the voltage here is 9 volts. Now to find the voltage here, it will be the difference of voltage from here to here. All right. So as the current continues passing through it, it's going to be 9 minus 3000 times 0.001. And the voltage here will be 6 volts. So to find the voltage here, it will be 9 minus 6, so it will be 3 volts. Alright, now we have enough information to find the energy stored at each capacitor. So for the 20 microfarad capacitor, it's equal to 1 over 2 times the capacitor times the voltage squared. So this one will be 1 over 2. The capacitor is 20 divided by 1000, which is 0.02 times the voltage, so it's 9 squared. And that gives me 0.81 joules. Now for the 30 microfarad capacitor. Wait a minute. Sorry, I made a mistake. It's 20 divided by 1 times 10 to the power of 6. Sorry, you're supposed to divide it by 1 million, not 1000. My mistake. So it's going to be sorry, 0.00002 times the voltage, 9 squared, or just 2 times 10 to the power of negative 5, both work. So 0.00002 times 9 squared divided by 2, you get 0.00081 joules. Okay. Now for the 30 microfarad capacitor, it's 1 over 2 times 0.00003 times 3 squared, and that will give you give me a sec, 0.00003 times 3 squared divided by 2. That's 0.000135 joules. So those are your final answers.